Alrighty. Hello, everyone. My name is Newt, and today we're going to go over this problem. So first of all, the first thing that I think of is to make a graph, because for me, graphing helps me visualize these problems really well. So I don't exactly know what y equals 1 over x squared looks like, but I can assume, because of the inverse relationship between y and x, that it might look something like y equals 1 over x. So I'll draw that right here. And then we know that there's a line at x equals 5 right here, and then y equals 4. So that's sort of an approximation of what this graph looks like. And now what I would think is the next step is you need to find the area bounded by these regions. So it might be kind of tempting to say like, oh, see, these regions, they're bounded. Let's just find the area within here. But that's actually incorrect, because we need to find the area bounded by the 3 lines. So actually that area is right here, this area. So how in the world do we even find this area? And that's a good question. So what we need to think about first is we need to think about, what are our constraints for this function? And I think the first thing that I'd want to start with is saying, okay, so what are our ending x values and y values? And so let's solve for those. So we know that this line, x equals 5, so we know our upper bound for x is going to be 5, and let's call this b. And then let's say the other bound is defined by this point right here. So to get this point, you need to solve for x. So I guess you'd say 1 over x squared equals y equals 4. So that's how you're setting those values together. You get 1/4 equals x squared, and then you square root these values, and you get x equals 1/2. So then let's say that at this point, the lower bound is 1/2. And then you may be wondering why I'm saying a and b. Well, it turns out that there's this nifty little formula that you can use to find the area between certain curves. And I'm looking just at the form that looks at the two functions with respect to x. And so this formula is going to be, in fact, let me just clear this off really here. Sorry about that. But I still want to see the graph. So it'll be a for the area equals the integral from a to b, where those are limits of integration, of the top function minus the bottom function with respect to x. So why does this top minus bottom thing even matter? And that's the reason for this is because it's essentially just finding the difference in your y values. So if you think about it, like this is the top function, this is the bottom, right? Now, if you're just finding the y right here minus the y value of the bottom function, which, let's make this green, is going to be right here, then what does that give you? That gives you that little slice, and say you actually extended this out as you go along, that would give you this top value minus the bottom value would just give you this area in the middle, right here. And so just because you're subtracting the top function minus the bottom function just means that you're getting the area between the two curves. So what does that mean? That means that you can basically now use this formula and just plug in some values. So you'd get a equals the integral. We already solved for these limits of integration from 1/2 to 5. And that would be the top function is going to be y equals 4 minus the bottom function is 1 over x squared with respect to x. Now, what I'd like to do for the integrals is kind of split it up into parts. And so we know the integral of 4 is going to be 4x. That isn't too crazy. However, we do want to know the integral of 1 over, let's say, negative 1 over x squared, right? So what I'm going to leave out the dx just to make it a little bit faster. What I would do is I'd take out the negative out front, and I'd convert that to just the singular exponent with the base just being x. So what I mean by that is I'd say the negative integral of x to the negative 2, because negative 2 to a power to the negative, when the exponent is negative, it means that it would go to a positive exponent in the denominator. So we're just doing the reverse of that. And from there, you can use the power rule, which is where you add 1 to that exponent and then take that number and put that in the new denominator. So you'd get the integral of x to the negative 1 divided by negative 1. And as you can see, these values right here, they cancel. So that means that leave you with, in this integral all the way down here, you get plus 1 over x. And now you know that these values you have to substitute in your limits that you found earlier. So that would be 1/2 and 5. And that would just give you substitute in the values, 4 times 5 plus 1 over 5 minus 4 times 1/2 plus 1 divided by 1/2. No, you don't need second parenthesis, whatever. And so this value would give you, which then equals 21/5 plus 1/5 minus the whole value of 2 plus 2, if you do those algebraic things out. So that'd give you minus 4. And this becomes 16/1/5. Or that would equal 50 plus 30, 31/5. And there we go. And obviously units squared because it's area. So that is your answer. So as a recap, we went up here. We sort of draw out the graph. You want to identify which area, like which region you're trying to find. And then you can solve, use this area equation right here. And then solve, given you need to know whether, like what these limits are. And so you want to solve for those by finding the rightmost point and then the leftmost point if you're looking at it with respect to x, in which case we knew was x equals 5, so that would be the top limit. And then you solve for the leftmost limit. In this case, it would be a equals 1/2, and then you can plug in those values, knowing that the top function is y equals 4, the other one is y equals 1 over x squared. And from there, we sort of looked at how to integrate this one integral, negative 1 over x squared, and then by hand, and then you plug it in to and essentially find, you can basically make this notation here and then plug in all those values and then get your numerical answer, which is 31/5 units squared. So I hope this is helpful, and I hope this is a good explanation. So that is all for today. Have a great day.